My talk is titled Identification of Risk Factors for Arterial and Venous Thromboembolism. More specifically, I focus on identification of the plasma biomarkers that can be used for risk prediction in both arterial embolic disease like stroke and myocardial infarction, and also venous thromboembolism. I will touch upon some of the challenges, some of the novel approaches you can take. I think we will see that we can improve risk prediction when it comes to future thromboembolic events. We know today a number of risk factors like smoking, BMI, hyperlipidemia, age, etc., but they're still too imprecise even when we combine them into risk scores. What we are looking at is actually how these factors affect plasma biomarkers, and specifically from the endothelium. And we think these, by being some of them linked to the pathogenesis, could improve the individual risk prediction, actually be used in what we call precision medicine. The field will develop into quite an interesting area. The main challenge is still, and has been for a while, to identify these specific biomarkers that we can use in the clinic. One major challenge is actually that we have started to realize that a lot of these, especially in the plasma protein biomarkers, are very much influenced by BMI, body mass index, obesity, sex, etc. So the classical biomarkers we use today, we have reference intervals based on the population, but we may end up that we actually have to do a more individualized reference range and take into account this individual variation we see in population, where persons can be rather stable individuals, but they can differ significantly in amounts. And I think this could be part of the reason why still, despite that there's so much research into identifying biomarkers, that there are so few new ones actually going into the clinic. It's basically one of the most important, especially when you are into this in what we call translational science, the intersection between clinic and experimental research. You are highly dependent on your collaborators. I mean, this is nothing you do in your own lab or in your own hospital. Yeah, you basically need to be well connected and have large multi-center collaborations. You have to realize that it will not be 8 to 5 work. And if you want to have a PhD to get a scientific background, but your main aim is to do a clinical career, you should choose your subject within like a clinically oriented one. But if you're really interested, I think the most interesting path we have in the intersection between the clinic and the experimental one. And if it's your hobby, yes, you will have a very interesting professional life until you retire, I think.